We're going to start here a discussion of rational exponents. All of these here should be relatively familiar to you, and I know that's like maybe asking a lot, but in theory, you should have seen all of this stuff here before. All of these exponent laws, they all still apply. The ones that we're going to be specifically focusing on here for a second are these two down here that basically, remember, if you have a negative exponent, it just puts whatever that is on the bottom. And then more importantly, not more importantly, but just as importantly, if you have a fraction in the exponent, that's like taking the root of it. So like if you had, well, I don't know, like 16 to the 1/2, that's really like saying 16 with a 2 there, which is really just the square root of 16, or 4. Okay? So to make sure you remember how to use some of these, we've got, I don't know why I erased that, but oh well. To make sure that you remember how to use some of these, I've got some examples that I want you to take a look at and see if you can work through them. So take a look at these here. Pause the video, go try to work these, see if you can get the answers, and then come back and see if you're right. Okay. So now, assuming that you've done that, this would be just like the one we did. So 4 to the 1/2 power literally means the square root of 4, which is 2. 64 to the 1/3 power is the cube root of 64. So what times what times what is 64? And I believe it's 4, right? Because, yeah, 4 times 4 is 16. And then 16 times 4 is 64. Yeah, so 4 cubed is 16. So the cube root, 4 cubed is 64, so the cube root of 64 is 4. Alright, this one is really not meant to be tricky. The 6th root of 0. Well, just remember, the only way to get to 0 is through 0. So 0 to the 6th is 0, so the 6th root of 0 is 0. Let me try to write the backwards version. So 2 squared is 4. 4 cubed is 64. 0 to the 6th is 0. So that's where these answers are coming from. Okay. Now for something like this, we kind of have to go back and remember, okay, well, what does this mean? Really means that we need to apply the 1/2 power to both the top part and the bottom part. So the first one is the square root of 1, and the second one is the square root of 16. So 1/4. Not bad. This is another square root, but it's got a negative out front. Remember that the negative out front means the negative is quite literally out front. It has nothing to do with the square root. It's just right in front. So negative square root of 9 is negative 3. This one, on the other hand, the whole thing is raised to the 1/2 power. So we're really taking the square root of the entire thing. We don't know how to do this yet, so we're just going to leave as is. Leave as is. Now for this one over here, again, we want to apply this to both terms inside. So we have the 4th root of 81 times the 4th root of x to the 8th. Alright, so what times what times what is 81? Well, 9 times 9, so that'd be 3 times 3 times 3 times 3. There we go. So this is, I know, 3 to the 4th is 81, and that means the cubed root of, or the 4th root of 81 is 3. There's a couple of ways to get the second one. I would probably just kind of reason it out, but to say, okay, what do I need to do 4 times to get x to the 8th? I take x squared, and I raise it to the 4th power, where those two will multiply together, and that'll give me x to the 8th. Okay? And this one over here I don't think we can actually do much with. I think I just kind of wanted you to either write it like, to recognize that it would be like this. Cube root of 5 times the cube root of y. Okay? Now, this particular problem brings up a kind of a newer idea, because rather than maybe writing this as the fourth root of x to the 8th, you could have said, well, can I just multiply those exponents together? The answer is yes, you could. If I have x to the 8th to the 1/4, I can multiply those together and also get x squared. Okay, so it's not that there's only one way to solve these. You solve it the way that makes the most sense. But in general, it's probably going to be very helpful to turn things into roots, especially when they're numbers, because, you know, this cube root of 64, the square root of 4, or something like that.